we have to change the gas, this liquid, to a gas. To do that, we have the compressor here that's taking in the product and pumping it at high pressure out to a valve. And that valve is sort of shaped like this. And this is what we call the low side and high side. So this is high side, and this is the low side. What happens here? The superheated compressed gas comes to here, and as it hits this larger area, from this very small area to a large area, it expands. When it expands, it changes phase. When it changes phase, it allows it to come from a liquid to or from a superheated gas rather, to a liquid in here. The problem with this is when H2O, hydrogen, hydrogen, one oxygen. Okay? Hydrogen is polarized positive, slightly positive, whereas the oxygen is slightly negative. This is why they attract to one another and they form water. As this comes through and it drops pressure, that H2O, this right here, goes through a change as well. It goes from being hot to frozen. And it creates ice crystals, just like snowflakes. Snowflakes are beautiful when they're outdoors. They're not so beautiful when they're in your air conditioning system. It impedes the operation because part of the system here, remember we talked about taking heat and moving it. This is the part right here, and the coils that follow it, that will take up heat from inside of the house. So this is inside the house right here, and here's the heat that gets absorbed into this system here and gets flushed away back out to outside where it now loses that heat. If there's ice crystals right here, due to the H2O content within the system. And this is new systems and old systems, okay? They both have water in them. Moisture vapor. It's just different varying amounts. So, if we have ice crystals, and let's say we can only absorb 70% of the heat that's actually possible of being done based on the system design. So we're only doing this. Well, what does that mean? If you're only taking 70, that's good, isn't it? It's doing its job, right? No, it's not, because 70% is not 100%. Okay? We want to try to achieve 100% absorption inside the house and 100% repel outside the house so that we get a good heat transfer with less work. If we're only doing 70% absorption, that means that this motor over here has to run 30% or more longer to achieve the goal that we're after. So, I know it's all confusing, I'm trying to do this really, really fast, but our whole goal here is to somehow get rid of this moisture in this entire system, because it is a closed system. All right, the moisture went in when they put in the Freon, the moisture went in when they put in the oil, the moisture went in when they built the system. There's no way to evacuate it all out. You can't boil the whole system out. Okay. So, what we did is after 12 years of research and development, 5 years of actual testing, we've come up with a chemical way of dealing with this that will actually take and break the bonds between the oxygen and the hydrogen. Our product will actually absorb these two products right here, the hydrogen atoms, and turn them to nothing. They'll actually become part of our product in the flow, which is a lubricant, leaving the oxygen to sit on its own, but oxygen doesn't freeze. It's minus the hydrogen atom, so it freezes. It won't freeze, rather. So, we've taken a long time to figure out how to do that. It's proprietary. I wish I could show you exactly how it does it, but it has to do with the fact that the polarity here is negative, and the polarity on the hydrogen is positive, and a nanosecond, and I mean a nanosecond, constantly, these two items, all they're attached, are separating, boom, boom, and putting back together, so they're bouncing on each other for nanoseconds at a time. What we've done is designed a product that when that bounces, our product actually comes in and says, you can't stick to each other anymore. And then we've created in our product a stronger negative pole. Okay? This is a weak negative pole. This is a strong negative pole. What's going to happen? When these break apart, these items are going to become part of our product. And our product is ready to absorb them without having any ill effects, no negativity. So we're going to take that away. And that's it. That's the whole thing. That's all it takes. It's a very simplistic attitude towards it, and it achieves the goal. So with that, now we take all this out of here. There's no more ice coming through the system. The system's flowing, it's doing its job, it's pulling in 99% of its capabilities into heat, because you're going to lose some via dust and ambient moisture on the outside of the system as well. And we've all seen that. The outer tubes get a little frost on them, so you're going to lose a little bit there. But 99% is better than 70%. It's better than 60%. It's better than 50%, because we've seen them that low. Refrigeration systems running as low as 50% of their capability due to nothing more than H2O in the system. And once our product was introduced, that went away, and it visualized itself in the customer saving a lot of money. So that's the basics of AC. And from me to you, I hope this has been informative. If you need more information, stop your rep, talk with your rep, ask him questions. We want you to fully understand it, but again, it's a very simplistic chemical reaction that's taking place, and we basically will increase the system's performance, increase the money-saving capabilities, and we also will provide that system a longer life, because it's not working as hard, it's not building acids inside that corrode it and break down the electrical dielectrics within the motor. So all these things are alleviated in one product, and one product only. This is the only product of its kind that we're aware of anywhere in the world, and it will help you with your system needs and protect you for years to come. Thank you.